There we go. All right, ladies and gentlemen, we are going to be doing our side, angle, and angle, side lesson today. Our objective is that you will be able to prove that triangles are congruent using the side, angle, and angle, side theorems. Okay. Now, up to this point, when we did 5.2 and we talked about congruent figures, we've been told that things are congruent. We've been told that two triangles are congruent, just like we saw in our warm-up. We were told that two quadrilaterals are congruent. So we've been told that we have a congruent figures, and then from that, we've identified our congruent parts, okay? But sometimes we have to work reverse. Sometimes we're given two figures and we're asked, are they actually congruent? Are these figures congruent? Well, if those two figures are triangles, normally in order to show that things are congruent to each other, you would have to show that every single pair of corresponding parts are congruent to each other. So if I wanted to show that these triangles were congruent and I didn't have these theorems, I would have to show that each one of these corresponding sides are congruent to each other. I would then have to show that each pair of corresponding angles are congruent to each other. So I would have to show six, right, three sides and three angles, six pairs of corresponding parts being congruent to each other. And that becomes a large feat. That becomes difficult to do. Luckily, though, if we have triangles, if we're working with triangles, we have these nice theorems that cut down the number of things that we have to show that are congruent to each other, okay? And it cuts it down to three things. So we have to show only three congruent corresponding parts for each theorem. Instead of six, we only have to show three. But here's the thing, some of these theorems are very specific as to what types of parts and where those parts should be, okay? So we have to pay attention to the theorems, okay? So let's start us off with the simplest of the theorems, okay? The simplest of the theorems is the side congruence theorem, also known as SSS, side. So S stands for sides, A's stand for angles, okay? So the SSS congruence theorem is the side. Now the theorem tells us exactly what we need to show. If I have three sides of one triangle and they're congruent to the three sides of the second triangle, then the two triangles are congruent, okay? So in order to use the side congruence theorem to show that two triangles are congruent to each other, meaning they are identical to each other, right? In order to use this theorem, I need to show that the three sides in one triangle are congruent to the corresponding three sides in the second triangle, okay? So in this image here, we have triangle ABC and we have triangle DEF, okay? Now, if I have triangle ABC and DEF, I clearly have markings here on these triangles. So I can list my congruent corresponding sides, okay? I can list my sides here. So I can see based on the tick marks here that side AB is congruent to side DE. So AB is congruent to DE. This one pair is one of my sides. Okay, next I have side BC from this triangle has two tick marks. and that's congruent to side EF on this triangle, which also has 2 tick marks. So side BC is congruent to side EF. That's my second side. And third, I have AC that has the 3 tick marks and DF that has the 3 tick marks. So side AC is congruent to side DF. That's my third pair of sides. So I have side, side, side. So how do we finish this? What's my final statement? Once I've shown the 3 parts that I need to show, we write a congruent statement. Triangle ABC is congruent to triangle. Okay, matching my parts. A to D, B to E, C to F. So D, E, F. Triangle ABC is congruent to triangle DEF by, okay, the side, side, side theorem. By the side, side, side theorem. Okay. So the side, side, side is probably the easiest of them because it only involves sides. Okay. And no, there is no such theorem, congruence theorem, as angle, angle, angle. Okay. You can't prove 2 triangles congruent using angles. Only sides. Okay. But you can do a combination of sides and angles. So there's a lot of different combinations. We have the side angle side. We have the angle side angle, and we even have the angle angle side. Okay. Now, these are very important in the order that the parts are in the triangle. Okay. They're very, very important. So let's take a look at the side angle side congruence theorem. The side angle side congruence theorem uses 2 sides and 1 angle. Okay, so it uses 2 sides and 1 angle. But the trick here is where the angle is compared to the sides. Okay, you have to have the angle in a specific place compared to the sides. So it says if 2 sides and the included angle, and we'll talk about what included angle means. Okay, if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the two triangles are congruent. Okay, so 2 sides and 1 included angle. Okay, so let's take a look here. Okay, I'm going to do this as clearly as I possibly can. We have 2 sides and we have 1 included angle. Looking at these 2 triangles here, triangle ABC and triangle DEF, okay, I can see I have these sides right here, okay? So side AB and side DE each have 1 tick mark, so they're going to be congruent. So this is going to be one of my sides, my side pairs right there, side and side, okay? That's one of my side pairs, okay? The other one of my side pairs is right here. We have side AC and we have side DF, sorry, AC and DF, okay? These do both have 2 tick marks. So this is my second side right here. That's my second side. So I have this side and this side, okay, and then I have this side here and this side here. Okay, the angle that I need must be the included angle between these sides, okay? The included angle. So what does that mean? That means if I take these two sides and I look at them, it's pretty much the angle that these two sides are creating when they meet. Okay, so we're talking about these angles right here. This angle is my included angle for these two sides here because it's the angle that's being created by those two sides. Similarly, this angle here is my included angle for these two sides, right? It's the angle that's created by those two sides right there. So the included angle is essentially the angle that is created by the two sides that you're using. So if you want to use the side angle side theorem, the angle that is congruent must be the angle that is between or being created by the two sides that you're saying are congruent. So over here, I have my side AB is congruent to side DE. That's one of my sides, like I said, okay? I have my side AC right here is congruent to one of my sides DF right there. That's my second side. So I have the two sides that I need. I have the two sides. The angle that I have that's congruent is angle A and angle D. So I know that angle A is congruent to angle D. This is my angle, okay? So I have to make sure though, is angle A and angle D, are these two angles included between the two congruent sides that I have, two sets? So I look at angle A. Is angle in between my two congruent sides? Is it the angle that is being created by those two sides where they meet? Yes, it is. Is angle D the angle that's created by the two sides where they meet? Right here. Yes, it is. So this is my included angle, which means I have side, angle, side, side, angle, side, side, angle, side. Okay. So at this point, I can say that triangle ABC is congruent to triangle DEF by the side angle side theorem. Okay. By the side angle side theorem. I'm going to give you guys 30 seconds to get that down, and I want to talk about all the different ways you can have an included angle here, okay? All the different ways you can have an included angle here. So I'm going to zoom in on that. There you go. I'm sorry, that looks like a little bit like a P. All right, so our included angle doesn't have to be angle A and angle D. It doesn't have to be those two corners. The included angle depends on which two sides are being used in the triangle, okay? So I wanted to show you guys here. So if I had in my triangles, if I had this side and this side as the two sides that are being used to be shown congruence, then the included angle for this side AB and side BC is angle B. Okay, so the included angle for side AB and BC would be angle B right there. However, suppose I was using side AB. Let's say I was using side AB, and instead of BC, I was using side AC. Side AB and side AC. Okay, these two sides right here. So this time, since if I'm using these two sides, right? These are all different scenarios, guys. These are all different scenarios, okay? So if I were to use side AB and side BC, then the included angle would be angle A here with those two sides, this side and this side, okay? Lastly, that leaves angle C here. Well, if I were using side BC and side AC, if I were using side BC and side AC, then the included angle would be angle C right there. Oh, I apologize for the crookedness there. Okay. So depending on the two sides that are being used in your triangle, your included angle will change, right? It's based on which two sides you're actually using, which two sides you're actually able to prove that are congruent. So it's not like I'm just going to randomly choose two sides. It's about which two sides you have information about, right? Okay, so that's our side angle side theorem. That's our side angle side theorem. Okay, two sides, one angle. But the angle must be the included angle. Okay, there is no such theorem as like the side angle. There's no such theorem like that. There's no such theorem as the angle
Miss Faye?
side. Question?
Yeah, sorry for the interruption.
No worries.
Can I get the name of the notes again? I can't find it here.
It's the 5.3, 5.5, 5.6, side angle, angle, side angle, and angle side.
Is it on modules or on pages?
It should be on, give me a second. Continue. So here we go. We are talking about now, we're going to talk about angle, side, angle, congruence theorem. The angle, side, angle. And if you'll notice the order, right? Angle, side, angle. It means that we should have an angle, a side, and then an angle, where the side is between the two angles. Right? Just like side angle side meant the angle needs to be between the two sides, the included angle. With angle side angle, we now have two angles. Okay, this time around we have two angles, pairs, and one side pair. But we have to make sure that the side is included between the two angles. Okay, so the side has to be the side that's between the two angles. So let's take a look. If two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. Okay, then the two triangles are congruent. So we're talking about an included side once more, okay? So let's take a look here. We're gonna have two pairs of angles and one pair of sides. So if I take a look at my diagram for triangle ABC and triangle DEF, okay? Over here, I see angle A and angle D both have one arc. They each have one arc. Okay, so that means that angle A is going to be congruent to angle D. That's one of my angles there. Okay, so my angle A is congruent to angle D. That's one of my angle pairs. Okay, then I can see that angle C here has two arcs and angle F has two arcs, which means this is going to be my second angle pair right here. So angle C is congruent to angle F. I'm given this information. I'm not making it up. I'm not pulling it out of thin air. It's right there, plain as day for me to see with the arc marks. They're telling me they're congruent, right? And that's like the easiest way that it can be, like where they tell you with the symbols. Sometimes they don't tell us with the symbols, and we have to use our prior knowledge. We have to use definitions, and we'll talk about situations like that. Okay. So this is our second angle pair right there. And then we have our included side. We have my two angles. I need my one side, but that side needs to be the included side. So what does that mean? That means I take a look at my two angles, angle A and angle C. The included side is going to be the side that's right between those two angles, okay? Side AC. The included side here is going to be the side that's right in between my two angles there, side DF. So the two angles that are being used in triangle ABC are angle A and angle C. So the side that's included is going to be side AC. See how that works? The two angles that are being used in triangle DEF are angle D and angle F. That means the side that is included between those is side DF. And I can see that I'm given that they are both congruent. I'm not pulling it out of thin air. I'm not writing it down because it's convenient for it to be written down, okay? It's given to me that they are congruent. So this is my side, and it is my included side, okay? It is my included side. So I have my angle, I have my included side, I have my angle. So I have an angle, side, oops, didn't write the sides there. I have angle, side, angle. I have angle, side, angle happening, okay? Angle, included side, angle. Angle, included side, angle. Therefore, I can say that triangle ABC is congruent to triangle DEF by the angle, side, angle theorem. By the angle, side, angle theorem. Okay. So I'm going to do the same thing here as I did up here, except this time around, I'm going to show you if we had the two angles, which one is the included side for those two angles. So for example here, let's say I have angle A and angle B being used. Okay, so angle A and angle B, I'm coloring them pink. So the included side between these two angles is side AB, right there. Okay. Next, suppose instead of angle A and B, we have angle A and angle C. Suppose we have those two angles being used. In that case, then, the included side is going to be side AC, right there. Suppose that the two angles that we were using were side B and side C. I'm sorry, not side, angle B and angle C. Woo, brain fart. Suppose it was angle B and angle C. That means the side that would be included here would be side BC. Okay, just to dry up. I give you guys a second there to catch up. Okay. And then we have our last theorem, ladies and gentlemen. And our last theorem is very similar to the angle side angle, except of where the side ends up being. Okay. So angle side angle, ASA, the side must be included. But let's say your side is not included. Let's say you have two angles and a side, but it's not the included side. Do not worry, my friends, because there is a theorem for that, right? There isn't one where you have two sides and one angle, but there is one where you have two angles and a side. So this theorem of angle side again uses two angles and one side. The difference being is that the one side is not included. Where is it? Non-included side. Okay. The difference being is that for this theorem, angle side, the side is not included. So if you have two angles and a side, you just need to figure out, is the side included or is it not? If it's included, then it's angle side angle, ASA. If it's not included, then it's angle side, AAS. Okay. So for this, we have two angles and a non-included side of one triangle are congruent to two angles and a non-included side of the second triangle. Then the two triangles are congruent. Okay. So let's take a look here. I have angle A is congruent to angle D. Okay, that's my first pair of angles right there. Angle A is congruent to angle D. Okay, that's my first pair of angles. Second pair, I have angle C and angle F. I have my two arc marks. So this is my second pair of angles. So angle C is congruent to angle F. Then I need one side. I need one side here. And that one side that I'm given that is congruent is BC is congruent to EF. So I am given that side BC here is congruent to side EF. So here is my side, here is my side. Okay. Side BC is congruent to side EF. Okay. Looking at your triangle, notice that side BC is not between your two angles in this triangle. Side EF is not between the two angles that are congruent in this triangle. So you have angle, angle, and a non-included side. Angle, angle, and a non-included side. Okay? So we then can use the angle side congruence theorem, and we can say that triangle ABC is congruent to triangle DEF by the angle side theorem. Okay, because the side was not included. Okay, so to recap, okay, here, hold on, let me zoom a little because I know some of you guys are still writing. We first had our side. It is the only theorem where all three things are the same. They're all sides, okay? So side congruent theorem. That's when all three of the parts are sides. And then we have our angle side congruence theorem, where we have two sides and the included angle. Two sides and the included angle. So side, angle, side. And then we have our two theorems that are two angles and one side. One of them, the side is included, and that is the angle side angle, where side is written in the middle, right? Because the side is in the middle of the two angles. And then we have the angle side congruence theorem. And that again, two angles, but notice the side is written last or, first, or however you want to look at it. But you have the two angles and the one side that is not included. Okay. So you need to be able to recognize that difference. Okay, there is no switcheroo of the side angle side congruence theorem. It is just side angle side. And then of course there is no such thing as an angle theorem for congruence. Okay. So these are the four theorems that we're looking at. So if we go into our examples, give me one quick second, guys. So we're going to go ahead and we're going to do a few examples here. And we want to essentially Go through and look at each pair of triangles that we're given and determine whether the congruent statement is true and explain why we think it's true, which theorem makes it true, okay? So for example one here, triangle ABC is congruent to triangle EDC. They're saying
Miss
determine,
K,
yes,
those tick marks are kind of hard to see. Maybe you could zoom in a little more, or
absolutely I can. Here we go.
thanks.
I can also make them darker here.
Yeah,
So
that might help.
let's see, we have this one and this one. We have this one and this one. And then this one is 1, 2, and 1, 2. So hopefully that helps a little. There you go. Okay, so we want to decide whether the congruent statement is true and explain our reasoning. So let's take a look here. Triangle ABC is congruent to triangle EDC. Now, these two sides and these two sides, they each have one tick mark, which means they're all congruent to each other. So how did I know that AB was actually matched up with ED? I use the statement up here. AB, ED, they're the first two letters. So that means AB goes with ED. BC, DC, they go together here. And then of course, these two had two tick marks. So that meant that those were congruent, okay? So take a look at this. I have congruent pairs of sides. I have AB, side AB is congruent to side ED. I see it here. Okay. I see here that side BC is congruent to side DC. It's given to me with the tick marks. And then I see that side AC here is congruent to side EC. So I have three pairs of congruent sides. I have side, I have another pair of sides, I have another pair of sides. So my decision here is that yes, the congruent statement is true because of the side, side, side congruence theorem. So I can say up here, triangle ABC is congruent to triangle EDC by the side, side, side theorem. I know it's a tight space, guys, I'm sorry. Okay, by the side, side, side theorem. Because I have congruent pair of sides, I was told. I have congruent pair of sides, I was told. I have a congruent pair of sides, I was also told that. Okay. Let's take a look at B. I have triangle KGH. KGH. So this triangle right here is congruent to HJK. HJK. Okay. Looking at these two triangles here, I see here I have a tick mark on GH and I have a tick mark on KJ. Each one is 1. So that means that they are congruent there. I have 2 tick marks on GK. I have 2 tick marks on HJ. So I know that those two are congruent. So far, I have that GH is congruent to JK. Okay, that's a side. And I have GK is congruent to, oopsie, miswrote that. GK is congruent to JH. Okay, GK is congruent to JH. That's another side. Okay. So I have 2 sides. So that means that it can either be side angle side, or it can be side side side, because these are the only two angles that have two sides, or two theorems that have two sides. So I can either try to find a third pair of sides that are congruent, or I can try to see if there's an included angle that's congruent. So if I take a look at my triangles, if I'm looking at just this triangle with the two sides here, I have to show that angle G here, because it's the included angle between my two sides, angle G is going to be congruent to the included angle between these two sides, which is angle J. Okay. But I
Can you
don't
move
have
it a little bit to the left,
Sure.
please?
Yeah.
Thank you.
So I have to show that these two angles are congruent, or I have to show that this side HK is congruent to side HK. Okay, so something beautiful is happening here. Look at this side HK. Look at side HK. It's a side that's being used for both triangles. Okay, it's a side that's being used for both triangles. That actually is helpful to me, because if you looked in the mirror and you put your hand in the mirror, is your hand your hand? Is the hand that's being shown in the mirror the same hand that's in real life?
Yes.
Yes, right? So your reflection is you, right? We're looking at a regular mirror, not one of those funny mirrors. Your reflection is you. So when you have two triangles that share a side, that side is congruent to itself, because it's essentially a reflection of itself. So we don't have to worry about angles here, because my gosh, there's no information about angles here for me. So instead, I can use this side that's being shared by both triangles, and I can say, hey, look, side HK is congruent to side HK, because, and there's a reasoning for this, by the reflexive property. Remember that property that says something is itself, right? That's literally what we're saying here. HK is congruent to HK because HK is HK. And it sounds obvious, but sometimes you forget that. Okay? So we can use this third shared side. So this is my third side here.
It's on,
Yes,
is
Bill.
the second one on blue? Is that GK or GH?
Oh no, that's GK.
GK. Okay.
Yeah,
Thank you.
I made a typo and I tried to correct it.
You can see it in the chat.
Yeah. Okay, GK is congruent to JH there. Okay, and then we have HK is congruent to HK, which means that these two triangles of KGH and HJK can be said to be congruent, again, by the side, side, side theorem. Okay, so we can say by the side, side, side theorem. Okay. Let's look at another example here. You have triangle UVW.
Can you
And
darken the tick marks?
XYZ. Yes, I will in a moment. Okay. Yes, I will in a moment. So in this triangle, we are given three sets of tick marks here for our sides. Okay. We are given one here and one here. Here, you know what? I'm actually just gonna draw the tick marks. I want you guys to list it out. And then I'm gonna ask you which theorem can be used here. Okay, I'm gonna put a poll up in a second because these are my U tries, right? So I'm showing that for a second more, for a little bit more, And for numbers 1 and 2, I want you guys to tell me which theorem can be used there. And I'm going to create a poll very quickly while you guys are working on the 2 U-try problems, okay? So at this point, you are working on these 2 problems for the U-try.
Could you scoot it over a little so I could see number 2?
Is that better?
Although I'm missing a letter
You're missing a letter.
on the corner. Yeah, there we go. Thank you.
Uh-huh. All right, so I'm gonna launch my poll for these 2. I'm gonna give you guys 2 more minutes to answer these, okay? So timer starts now on the poll. For you try number 1 and you try number 2. Okay, thank you to the 4 of you that have responded thus far. We have 1 more minute left. 30 seconds. Thank you to the 10 of you that have responded so far. If you are one of the people that have responded, please write to me privately in the chat so I know that you have responded. I don't need to know what your answer is. I just want to know if you responded or not so that I can make sure that you get some participation points. Thank you to the 14 of you, and we're going to end the poll now. Make sure that you're giving me whether or not you did privately. Okay. So I should get 14 responses here. Thank you so much, ladies and gentlemen. All right. Interesting results. Very interesting results here. Number 2 is a little bit worrisome. Number 1, however, 5 of you said side, 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 and 7 of you said side, angle, side. Okay.
Number 2 results makes me think that the number 1 correct answer for the first 2 is a fluke. I hate to say. What do you think?
Wait, what?
Well, it's just that the second number 2, the results there make
Yes.
me wonder if, because you could use SAS if you wanted to with vertical angles
For the first one.
for the first one, but it just
Yes.
makes me think that maybe the valid results for the first question may be just lucky. I don't know. See what I mean?
Uh-huh. That does bring up a good point, but that doesn't mean we're not going to talk about it. And so thank you, ladies and gentlemen. Those of you that are letting me know that you responded in the chat, you will most definitely earn yourself some participation points. So let's take a look. We have for number 1 on the U try, the number 1 thing was side angle side. Now, I'm curious to see which angle that you guys would be using. Which angle, if you're using side angle side, which angle would you be using? Which angle can you show that are congruent to each other? Because I don't see any arc marks for our angles here. I don't see any arc marks. And Mr. L did mention some vertical angles. And yes, if you remember back when, vertical angles are angles that are opposite or across from each other when 2 lines intersect, and they are always congruent. So which pair of angles here are our vertical angles? Okay. Well, first things first, side, side, side does work here because I have a pair of sides. I have a pair of congruent sides here and here. I have a pair of congruent sides there and there. Okay. So side, side, side for sure works here. The question is why does side angle side work as well? Okay. Well, if we take a look, we have these 2 sides here, or these 2 lines intersecting each other, which means that this angle here and this angle here are vertical angles. These 2 angles right here, one from this triangle, one from this triangle, they are vertical angles, which means that they are actually congruent to each other. Okay, they are actually congruent to each other. So I can say that angle SRT is congruent to angle QRP by vertical angles. So then if I say that, if I go for a side angle side, that means then I have to, so this is my angles. I then have to mention the 2 sides that include these angles. So the 2 sides that include this angle here are TR and SR. So TR is congruent to QR here, and SR is congruent to PR here, thus giving me my two sides here. So then I have side, angle, side, side, angle, side. Now for number 2, those of you that responded with side, 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 okay, you are correct. Those of you that chose angle, side, angle, I'm very confused. There's literally zero information here about angles. And I can't prove that angles are congruent. Like I have nothing at X or V. I have nothing at Z or W. I have nothing at angle Y and angle U. Like I have nothing there.
You know,
Nor
Miss
do I
K,
have
it makes me
vertical
think that
angles.
people are thinking, well, you know, those look similar, so I guess they are.
Oh, that's a common mistake. So if you are thinking that way, that is a very common mistake where you're like, oh, well, they look the same, so I can just use them. It is a common mistake, but it is a very bad mistake because you have to use the information that is given to you or that you can prove, right? In this situation, I could prove that these two angles are congruent because by the definition of vertical angles, like the diagram is actually showing me vertical angles. I can recognize that. So I can prove by the definition of vertical angles that these two angles are congruent. For these triangles here, I can't prove that any of these angles are here. I don't have any vertical angles. I don't have any congruent markings for angles.
Could I add something real quick?
Oh.
Guys, you need to understand when she puts an arc mark, a single arc mark with the same color on two different angles, that means those two angles are congruent to each other. Do you see that in that figure? For number 2, do you see any arc marks at all? There are none. So even though the angles look similar, that doesn't mean they are, and you cannot assume it.
So if you, Mr. L, you might remember this, but these kids might not have heard me say it enough. In geometry and in life, really, assumption is the devil. I always say that, and I know it's weird, but assuming something will get you into more trouble than asking about it.
Back in my day, they said it'll make a blank out of you and me. Do you know that one?
Yeah,
Oh, okay.
And a tushy out of you and me, I think, right? Assuming.
Yeah. You
Yeah,
don't want to make a blank out of you and me.
exactly.
Don't assume. Do not assume.
So don't. It goes the same here, guys. Read the facts. Use information. Use the facts that are given to you. In this case, the only facts that are given to us is about sides, and I don't have congruent. I don't have vertical angles to say that they're congruent. So so that means I use my sides. I have side VU is congruent here. 1 tick mark to XY. I think these diagrams switched. Yeah, I'm pretty sure they did. VU is congruent to XY. VW is congruent, 3 tick marks here to XZ. And UW is congruent to YZ. Okay, so I have side, that's another pair of sides, that's another pair of sides. Okay, so this would be by the side, side, side theorem. And I forgot to write this here. This is by the side angle side theorem, or you could have done side, 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 side. So number 1 could have been done using one of 2 theorems, side, 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 or side angle side.
We
But
learned a lot from your poll. That was really useful.
Yeah. Okay, we have 10 minutes left, and I do want to do a few more examples. So yes, we're going to continue on. So we're going to flip it over here. Okay, we're going to flip it over, and I'll give you guys 10 more seconds to get this down because I know I wrote that down quite quickly. Okay, so, and then we're going to flip it over and try to get some more examples in before you guys head out for the day. Remember that your homework is on Canvas this time. Okay, your homework is on Canvas this time. So let us see here. Flipping this over. Okay, go back to my zone. All right, so let me bring this up. We have some more examples here for you guys. Okay, and we're gonna try to work these out. I'm gonna move through these pretty quickly, and you have to listen. You guys have to realize there's a lot of my explanation happens in what I say. So you have to make sure you're listening. If you're just trying to copy down notes, you're missing out on a lot of stuff, okay? So you have to listen to the explanations and maybe write them down yourself. That will help you the most, okay? Let's take a look at this one. Triangle ABE and triangle CDE. Decide whether there's enough information given to prove the triangles are congruent, using specifically the side angle side congruence theorem. Okay, we specifically want to see if there's enough information to use the side angle side congruence theorem. So let's take a look. Okay. It says triangle ABE is congruent to triangle CDE. So we want to use side angle side. That means we're going to need a pair of sides. We're going to need an included angle, and we're going to need another pair of sides in order for there to be enough information. Okay. So let's take a look. In our diagram, we're told CE, side CE is congruent to side AE. I have one tick mark here. I have one tick mark here, right? So that's one of my sides. I have a side and I have a side. So CE is congruent to AE. So that's one of my sides. Another one of my sides here, I have two tick marks here and I have two tick marks here. Okay, which means I have another pair of congruent sides, DE. Excuse me. Okay, DE is congruent to BE. Okay, which leaves the angle, and my angle needs to be included. That means it needs to be between the two sides in each triangle. So this is my other side.
You can't see what you wrote next to the A.
Oh, my bad. It's really tiny, but I wrote included. That's supposed to say included. Okay. So if I take a look at just this triangle here, right? If I only take a look at one of the triangles, I have this side being used and I have this side being used. That means the angle that I need to show that it's congruent is this angle here, angle AEB. And then down up here in the top triangle, I have this side and this side, which means again, their included angle would have to be this angle here, DEC, right? So both of these angles are at vertex E. Now, if I take a look at these two angles here, I should be able to see that I have a pair of vertical angles. I have a pair of vertical angles that are directly across from each other, which means that these angles are congruent to each other because vertical angles are congruent to each other. So I can say that angle DEC is congruent to angle BEA by vertical angles.
So even though those two angles were not marked, we knew they were congruent because they are vertical angles directly across from each other. And that's why you gave an identical arc mark to each one.
Exactly. Thank you for that. Absolutely. I used the definition of vertical angles to show that even though these two angles did not have arc marks, the diagram and how they are created means that they are vertical angles. And the definition of vertical angles tells me that they are congruent. So I'm using facts, my diagram, and definitions to deductively, right, factually say that my angles are congruent. I'm not assuming that they are. I used my knowledge from chapters 1 and chapters 2. Definitions of vertical angles. Okay. So in this case, yes, there is enough information. So we can say triangle ABE is congruent to triangle CDE by the side angle side theorem. Okay. By the side angle side theorem. Okay. Let's take a look at B. We have 5 minutes. Let's take a look at B here. Okay. I have a few markings here. I have tick marks here for ST and SR.
What did you write in the bottom?
That part?
Yeah.
Okay. So I have tick marks here and here, which means those two sides are congruent. So I'm looking at triangle SAT, so SAT, and triangle SAR, SAR. So these two halves of the triangle, okay? So I have these two tick marks. I also have this symbol here. They're both boxes, which tells me that they're both 90 degrees. If they're both 90 degrees, then that means they're congruent for those angles. So that means angle SAT, this angle right here, and angle SAR, that angle right there, are congruent to each other. So I have a congruent side and I have a congruent angle. So I have a congruent side here. Side ST is congruent to side SR. And then I have a congruent angle here. Angle SAT, that angle right there, is congruent to angle SAR, that angle right there. Okay. But do you guys see a third congruent part? Is there a third, like, is there another congruent angle or another congruent side?
RA equals AP.
Say that one more time.
RA equals AT.
It would be nice if that were the case. If that were the case, we could use the SAS theorem, but are they marked with double tick marks? Are they both shown to be congruent to each other here?
No, they're not.
No, they look like it, but they're not marked.
Yeah. Nor do we know, like, we're not told that A is a midpoint, right? If we were told that A is a midpoint, heck yeah, because midpoint means it's in the middle. That means those are halves. I mean, it looks like A is a midpoint, but we can't assume that. But thank you for that contribution because that opened that discussion, right? Any other takers? Any that we can prove? What about this guy? What about that?
AS equals SA.
AS equals SA. By why? Why? Why can I say that? Why can I say that AS is congruent to SA? That's by what property?
We just mentioned it. Come on, guys.
It's on the front.
Reflective property?
Yes, reflective. Right? Is it reflective or reflective? I'm asking myself. Yeah, reflective.
Reflexive, isn't it? With an X?
Yeah, it's reflexive.
I think so.
Yeah, by the reflexive property. So that's another side, all right? I have two sides and I have an angle. Doesn't that look like side, angle, side? Yeah, I got side, angle, side. But here's the caution, guys. It doesn't matter what order you write it in. That's not what matters. What matters is what order it's in your figures. So I'm using this side right here. I'm using this angle right here. And I'm using this side right here. So what happens? What does that mean? Look at this. If I trace this, I have side, using that side. I have side, and then I have angle. I have side, side, and then I have angle. If I go the reverse way, I have angle, side, side. There is no such theorem that doesn't include the angle with two sides. I would need this angle. I would need to show that these two angles are my congruent angles. But I don't have information for that. Therefore, there is not enough information. Even though we have two congruent sides and a congruent angle, and even though we just went through all of that, if the order is not there, if my angle is not the included angle, nope, it don't work. It does not work. Okay. All right, ladies and gentlemen. Yes, I still expect you to do your homework. Yes, we will do more examples on Friday when we see each other, and we will have a full-on practice day on Friday with this. Please notice that your test date has been moved to next week. Your test is next Friday. Your test is next Friday. So please make note of that. Okay, next Friday is an odd day. So it's not a 50-minute period. It's actually an hour-and-a-half long period. Okay, so please make note of that. I will see you guys on Thursday to continue this and practice this information and really solidify it and get it down. Other than that, do your homework. Have a great day. I will see you guys on Friday.
Bye-bye.
Bye-bye.
But